Now I'm going to explain you about the optical isomerism. Usually this optical isomerism comes under stereoisomerism. Stereo is nothing but a three-dimensional space. The isomers which which are which differ the positions of substituents, atoms or groups in three-dimensional space, then they are called stereoisomers, and such type of isomerism is called stereoisomerism. So under stereoisomerism, optical isomerism is one of the type of stereoisomerism. Now, what is the definition for optical isomerism? Compounds having same molecular formula and same structural formula, but they differ in the direction of rotation of plane polarized light are called optical isomers, and the phenomenon is called optical isomerism. Right. So molecules having same formula, same structural formula, molecular formula, structural formula, both will be same. But even though the molecular formula and say structural formula are same, but they will be different. How they will be different means some of the compounds rotate the plane, they have the capacity to rotate the plane polarized light. So what is meant by plane polarized light? What is ordinary light? So ordinary light consists of the vibrations, the electric and magnetic field vectors will be present, which are vibrating in all the possible directions. In all the possible directions. Whereas in a plane polarized light, the vibrations will be only in one plane. Only in one plane. Such type of light is called plane polarized light, and this is an ordinary light. Now our organic compounds have the capacity to rotate this plane polarized light. So the rotation will be of two types, either clockwise direction or anti-clockwise direction. So if the substance, suppose this is the substance, if the substance rotates the plane polarized towards right side, then it is called dextro-rotatory substance. And if the plane polarized light is rotated towards left side, then it is called levo-rotatory substance. See, this phenomenon, the rotation of plane polarized light by a substance, is called optical isomer, and the phenomenon is called optical isomerism. So this compound, suppose if I take two compounds having same molecular formula, same structural formula, but one will rotate towards right side and one will rotate towards left side. So in this manner they will be different. Such type of isomers are called optical isomers, and the phenomenon is called optical isomerism. Now usually a device is there in which we can observe the rotation of plane polarized light. So what is the device? Polarimeter. Polarimeter is an instrument or device used to measure or know the rotation of plane polarized light. So with this instrument, I can know whether the substance is dextro or levo, or whether it is optically active or inactive. So what is meant by optical active means optical activity is nothing but the ability of a substance to rotate the plane polarized light either to left side or to the right side is called optical activity, and the substance is called optical active substance. So if the substance rotates the plane polarized light, then it is called optically active substance, and the property is called optical activity. If the substance do not rotate the plane polarized light either of the side, then it is called optically inactive or optical inactivity. Optical inactivity. So in which conditions the substance cannot rotate the plane polarized light? So let us see now. So just now itself I have given the idea about what is a dextrorotatory substance. So dextro is nothing but if the substance rotates the plane polarized light to the right side, it is dextro. If it is towards left side, then it is levorotatory. Usually a dextrorotatory substance is indicated with the symbol positive sign or small letter D. Example, plus lactic acid or D lactic acid. See, so if we come across any name such as plus lactic acid, then it is called that lactic acid is dextrorotatory, or D lactic acid, the lactic acid is dextrorotatory. Whereas minus lactic acid, the negative sign is used for representing levorotatory substance or small letter L. So L lactic acid or minus lactic acid. Minus lactic acid means it is levorotatory. So what do we know from these two means? This dextro rotatory, levorotatory. How do we know? So not by looking at the formula. We cannot predict the rotation of or the optical activity of a certain substance by looking at the formula. Only through experimental studies we can predict whether it is dextro or levorotatory. Now, so this is a dextrorotatory and this is a levorotatory. What happens if I mix those two substances in equimolar ratio? Then that mixture is called racemic mixture. See, an equimolar mixture of dextrorotatory and levorotatory isomers is called racemic mixture. Now, what is the optical activity of racemic mixture? Now I have an equal ratio of D lactic acid and minus lactic acid. So racemic mixture is indicated with the symbol both plus and minus. Plus minus. So if I have equimolar mixture of the plus lactic acid minus lactic acid, so what do we can we predict the optical activity? Means we know that the dextrolactic acid or plus lactic acid rotates the plane polarized light towards right side, and minus lactic acid rotates the plane polarized light towards left side. Suppose, so this is not exact, so for the clear understanding, suppose if the substance rotates to 10 degrees, plus 10 degrees, dextro is plus 10, levo is minus sign, minus 10 degrees. Why it is 10 degrees? The magnitude is same here. Why I am using the same magnitude means both are same substance, lactic acid, but they differ in rotation only, plus and minus. So that the net rotation is cancelled. It is 0. That means 0 degree rotation, no rotation of plane polarized light. So hence a racemic mixture is optically inactive because optical activity of one isomer is cancelled by the other. That is external compensation. Compensation means cancellation, balanced. So that is the optical activity of racemic mixture. So dextrorotatory, levorotatory and racemic mixture. Dextrorotatory is optically active, levorotatory is optically active, but racemic mixture is optically inactive. Now, what is the condition, important condition for optical activity? So, an important condition for optical activity is chirality, the concept of chirality. Chiral is nothing but hand. Chiral is nothing but hand. So, what is a chiral means? The objects which are non-superimposable on their mirror images. Mirror images. See, so as I said now, chiral is nothing but hand. So this is right hand and this is left hand. So according to the definition of chiral, the objects which are non-superimposable on their mirror images. So it is very clear that our left hand is mirror image of right hand. Now if I try to superimpose both the hands, so if I place exactly overlap these two hands, so that only one finger, middle finger will coincide but not the other fingers, so that we can say that these two hands are not superimposable. They are not superimposable. So such type of molecules or objects which are non superimposable on their mirror images, on their mirror, so these two are mirror images, they are not superimposable. Such type of molecules are called chiral molecules, and the property is called chirality. So this is the important condition for optical activity, and such type of isomers are also called enantiomers. Suppose if they are superimposable, then they are called achiral. Chiral is nothing but non-superimposable. Achiral means superimposable on their mirror images. So this is a simple example. This is 2-butanol. The first two are mirror images but not superimposable. A and B are chiral molecules. Whereas A and C, see here, they are not mirror images and also they are superimposable. So this is the concept of optical isomerism. Thank you.